As the planet warms, we're learning that climate change doesn't just mean hotter summers and weirder winters, it also changes the very quality of the sunlight reaching us. Specifically, it's intensifying ultraviolet (UV) radiation in ways that are sneakily harmful and surprisingly underdiscussed. The intersection of ozone depletion, shifting weather patterns, and even cleaner air, yes, sometimes that's a problem, is altering how much UV radiation reaches the Earth's surface. And it's not just equatorial beachgoers who need to worry anymore. Temperate zones are feeling the burn, both literally and figuratively. The ozone layer is often the star of the story, and for good reason. This thin shield of gas in the stratosphere acts as the planet's natural sunscreen, filtering out much of the sun's harmful UVB rays. In past decades, human activity, especially the use of chlorofluorocarbons (CFCs) in refrigeration and aerosols, punched literal holes in this protective layer, allowing more UV radiation to slip through. The good news is that international agreements like the Montreal Protocol have significantly reduced CFC emissions, and the ozone layer is slowly healing. The bad news? The recovery is uneven, and climate change is introducing new complications that weren't part of the original equation. One of those complications is temperature. The chemical reactions that destroy ozone molecules happen more readily in colder stratospheric conditions. As climate change cools the upper atmosphere while warming the lower layers, it may paradoxically create pockets where ozone destruction remains stubbornly persistent, especially over the poles and parts of the southern hemisphere. That's why UV levels in places like New Zealand and southern Argentina can still spike dangerously high, even outside of traditional summer months. But here's where it gets stranger. Even in regions with no ozone hole, UV exposure is increasing. One reason is air pollution, specifically the reduction of certain pollutants. In many cities, especially in Europe and North America, efforts to clean up smog and particulate matter have led to clearer skies. This is great for lung health, of course, but it also means more UV rays are getting through. Think of it this way. Dirty air used to act like a dull lampshade, muting sunlight. Now that the lampshade is thinner or gone, the UV switch is flipped up a notch. Add to that shifting weather patterns, like less cloud cover in some regions or longer, drier summers, and you have a recipe for prolonged, more intense UV exposure. In parts of Northern Europe, for instance, people are experiencing longer stretches of sunny weather than their ancestors did, sometimes without realizing the cumulative effect this has on skin damage and vitamin D dynamics. It's easy to forget that UV exposure is not just about how sunny it feels, it's also about how long you're exposed, how high the sun is in the sky, and what sort of invisible factors are filtering that light along the way. There's also the issue of behavioral adaptation, or lack thereof. People in traditionally mild, temperate zones may not have strong sun safety habits because historically they didn't need them. But with climate change nudging UV indexes upward in these areas, old assumptions are becoming dangerous. It's not just the tropics that require sun-smart behavior anymore. It's London, Berlin, Seattle, and Seoul. Ironically, some people might take this as an opportunity to bask in the sun for vitamin D, which, yes, the body needs, but the modern sun is not the same as the sun of 50 years ago. The UV that your grandparents soaked in with impunity may now come with a higher risk per minute of exposure. What used to be a leisurely hour outside might now be a stealthy assault on your skin's DNA, increasing the long-term risk of photoaging and skin cancer. Climate change is rewriting the rules of our relationship with the sun, and it's doing so with quiet force. While we often think of climate impacts in terms of wildfires or floods, the changes to UV exposure are more insidious, harder to see, easier to underestimate, and slower to reveal their consequences. Yet over time, they may reshape public health in significant ways, from higher rates of skin cancer in unexpected regions to altered vitamin D dynamics and deeper imbalances in how we interact with natural light. In short, the sky isn't falling, but the sunlight coming through it is shifting, and not always for the better. Our best defense? Awareness, adaptation, and maybe a little more shade.